Okay, so let's start by taking a look at the information on page 7-19. I do not have a copy of this page with me for whatever reason, so I'm just going to sort of wing it. When you look at this, we talked about atomic size, ionic size, and ionization energy. And we looked at trends. I'm just going to draw the periodic chart as a box rather than trying to draw in all the little shapes of it. So if we look at atomic size, as we're looking at the chart going left to right, size increases top to bottom, and it increases right to left. So what this means is big things are down here and small things are up here. We went over this last week before the end of the period. Then we talked about ionization energy, the energy required to remove an electron, and we said that we increase from bottom to top and from left to right. So that down here we have low ionization energies, and up here we have high ionization energies. So this allows us to see then that big things have low ionization energies and small things have high ionization energies. And this makes sense, and I think I gave you the example of grocery shopping with my kids, right? Where I had the baby tucked under my arm so no one could steal them, and holding the rest of my kids out in a long line, and the one that was furthest away could be most easily stolen from me. Right? That was before I started dropping them off and hoping they wouldn't come home when they were teenagers. They were horrible. But they turned out into nice adults anyway. So, big things, it's easy to steal their electrons. Small things, it's hard to steal their electrons. The most confusing of these trends is the electron affinity. And the electron affinity increases in a weird way. From bottom to top, you get larger negative numbers, which means you really get smaller numbers when you're just counting numbers. But when you're thinking of them as the amount of energy that's released, over here, this does exclude the noble gases, because the noble gases do not want any more electrons. So when we're talking about noble gases, they would have a really high positive electron affinity because they don't want to take on any more electrons. So now, when you look at this, you say, okay, we're just going through fluorine. So fluorine wants an electron. It's the most electronegative element. Things to the left, like lithium, don't want any more electrons because they've already got just a little bit more than a full shell. So when we look at this trend, fluorine releases a lot of energy when it gets an electron. It's the most electronegative element. Question?
Yeah. The first little box that you drew, is that for atomic size or ionic size?
Atomic size. Okay. And ionic size, cations are smaller than the atoms they came from, and anions are larger. And that was what we kind of went over really fast at the end last week, right? So when we're thinking of this electron affinity, things over on this side do not want any more electrons. So it would actually take energy to give them more electrons. Over here, fluorine wants electrons really badly. So it releases energy, and the whole energy of the system goes down when we give that the electrons that it wants. Now, I don't have page 7-21. So look at page 7-21 in your notes and just take a few minutes, work with the person next to you, and now go through and answer all of these questions. Which is bigger? Which has the bigger ionization energy? Which has the higher negative value? Just take a few minutes and do that at your seats. Yes?